Hello viewers, welcome to the online course on domestic equipment maintenance. Today I will start the session with air conditioner, basics, working principle and operation, which belongs to the module 9 on cooling equipment. In the previous module we have discussed on refrigeration equipment. Now the basic objectives of this lecture are to know the process of air conditioning, to understand the basic construction of an air conditioner, to explain its working principle, to identify the various types of air conditioner, and the last objective is to familiarize with some common technical problems encountered in an air conditioner. So let us start the session by introducing an air conditioner. An air conditioner is a device or system designed to regulate and control the indoor environment, including temperature, humidity, ventilation, and air quality in a closed space. It achieves by removing heat from the indoor air and dispersing it outside, thereby cooling the interior and maintaining a comfortable and habited environment. It achieves by removing heat from the indoor air and disperse it outside, thereby cooling the interior and maintaining a comfortable and habitable atmosphere. Air conditioners are widely used in homes, offices, vehicles, and various industrial and commercial settings to provide a pleasant climate for humans. It regulates our room's humidity, and the temperature should be between 20 to 26 degrees Celsius. Temperature, pressure, and humidity all affects the quality of air, and the air pressure does not change. Now let us discuss the process of air conditioning. The process of air conditioning involves mainly 3 steps. Number 1 is heating or cooling. Next step is the humidification or dehumidification. And the third step is the air purification or cleaning. There may be combination of these processes, for example, heating and humidification or cooling and dehumidification, etc. So let us discuss the first step, that is heating or cooling. Heating or cooling of a medium means that there is no change in humidity content of the medium while heating or cooling. It can be achieved by using a coil carrying a refrigerant. Refrigerants are chemical substances that change from liquid to gas or vice versa at specific temperatures. They also absorb heat from their surroundings and release that heat when they change from liquid to gas or vice versa. This addition or removal of heat changes the temperature only and maintain a constant humidity. The air conditioning process starts with the cooling step, where warm air from the indoor space is drawn into the air conditioner. The warm air passes over cold coils containing a refrigerant. This refrigerant absorbs the heat from the warm air, cooling it down. Next step is humidification, dehumidification. The process of addition or removal of moisture contents in any air sample is called humidification and dehumidification respectively. The air conditioning system works to control and adjust the humidity levels in the air to maintain a comfortable environment. Humidification and dehumidification processes are accompanied by heating or cooling processes. The third step, air purification or cleaning. The hot air drawn into the air conditioner system passes through the filters to remove dust, particles, and other contaminants, ensuring cleaner air for circulation. Next topic is the basic construction of an air conditioner. An air conditioner consists of various components that work together to cool and condition the air in an indoor space. The primary parts of an air conditioner are: number 1, compressor. The compressor is considered as the heart of the air conditioner because it works with a fluid that easily converts gas to liquid. It compresses the refrigerant and increases its pressure and temperature. It converts low pressure gas into high pressure, which commonly has a high temperature. The compressor is typically housed in the outdoor unit. The next component is the condenser. The condenser is also an outdoor component and it releases the heat absorbed from the indoor air into the outdoor environment. As the high pressure, high temperature refrigerant releases heat to the surroundings air, the condenser coil condenses it into a liquid state. Evaporator. Evaporator is located inside the indoor unit and linked to the condenser by a thin pipe. In the air conditioner, the high pressure gas is changed into a low pressure liquid. Due to the pressure drop, the liquid then turns into a gas. It is the liquid or refrigerant that cools and removes heat from the system. The evaporator condenses the fluid into a gas, which is then compressed by the compressor. The next component is the thermostat. The thermostat is the control interface that allows user to set the desired temperature. It signals the air conditioner system to start and stop the cooling process to maintain the set temperature. Expansion valve. The expansion valve regulates the flow of refrigerant from the high pressure side, that is condenser, to the low pressure side, that is evaporator. It causes a pressure drop, allowing the refrigerant to expand and cool down. Fan. Fans are used to circulate air over the evaporator and condenser. The evaporator fan circulates the cool air inside the room, while the condenser fan expels heat from the system to the external environment. Air handler and blowing unit. The indoor air handler of an AC unit is connected to the fan. It contains the blower fan, evaporator coil, and the other components needed for air circulation and conditioning. These parts of the air conditioner work together to circulate cool air throughout the room and draws air to the evaporator. The next component is the ductwork. It is used for central AC system. Ductwork is essential for central air conditioning system to distribute conditioned air to different areas of the building. It consists of a network of channels or pipes that carry the conditioned air in the central air conditioning systems. Filter. The air filter removes tiny particles such as dust, contaminants, and other impurities from the air before it is cooled and circulated throughout the space. In order to keep them from being circulated again throughout the space, these particles are captured in the filter. Cabinet or housing. The indoor and outdoor units are enclosed in a protective cabins or housing to shield the components from external elements. So, all these components that we have discussed now collaborate to attain effective cooling, dehumidification, and air circulation within an area, ensuring a comfortable and controlled indoor environment. Now you have a basic understanding of an air conditioner's parts. So let's discuss how the entire process functions. Working of an air conditioner. The thermostat of an air conditioner monitors and regulates the indoor air temperature. When the thermostat senses the need to reduce the air pressure, it activates both the internal and external components of the air conditioning system to initiate the cooling process. In the second step, the fan on the indoor unit pulls hot air through returned air ducts from the home. The heated indoor filtered air then travels over a cold evaporator coil. After that, the liquid refrigerant inside the evaporator coil cools the air passing over it. The blower fan of the indoor unit then circulates the cooled air back through the ductwork of the house and into the different living spaces. Through the copper tube, the refrigerant gas leaves the house and enters the compressor of the outdoor air conditioner unit. The compressor pressurizes the refrigerant gas before delivering it to the condenser coil of the outdoor unit. The condenser coil, aided by a powerful fan that forces outside air through it. During this phase, the refrigerant transitions back into a liquid state. Following this, it travels back to the indoor unit through a copper tube passing through an expansion valve that regulates the refrigerant flow into the evaporator coil. As the refrigerant cools, more heat is absorbed from the air and the cycle repeats. The next topic we will discuss now, the power rating of an air conditioner. The common rating term for an air conditioning size is the ton, which is 12,000 BTU, that is British thermal units per hour. An average central air conditioner will consume between 3 to 4 kilowatt per hour, while window units use between 1 and 1 to 4 kilowatt per hour. A 1.5 ton split AC typically consumes between 1.2 kilowatt to 1.6 kilowatt of power per hour. So dear learner, after going through the construction and working principle of an air conditioning system, let us now attempt some multiple choice questions to test our knowledge gained from this discussion so far. Well, dear learners, after going through these questions, now we discuss the different types of air conditioning systems. There are many types of air conditioning systems according to the season in which it is being used is classified as summer air conditioning, winter air conditioning, and year-round air conditioning. Again, on the basis of place of use, AC is classified as room air conditioning, central air conditioning, and vehicle air conditioning. Further, on the basis of construction of an AC, it is classified as window air conditioning, split air conditioning, packaged air conditioning, and chiller air conditioning. So, now let us discuss one by one. First one is the according to seasons. Summer air conditioning. In summer, both the temperature and humidity are high in outside air. Naturally, the air inside room gains heat and moisture, so it becomes necessary to cool and dehumidify the room air. It may be done by recirculating of the room air in an air conditioning apparatus by use of cooling coil. Winter air conditioning. In winter air conditioning system, generally the outside air is to be mixed with the inside air, and this mixture is to be heated and humidified. There are two main processes involved in this air conditioning. Number one, the mixture air is preheated with steam or hot water in a coil, and then it is saturated adiabatically and reheated. Number two process is the mixture air is heated and humidified in an air washer with pumped pre-circulation and external heating. Year-round air conditioning. It is also known as HVAC, that means heating, ventilation and air conditioning system. In some cases, simultaneous heating and cooling arrangements are required in the same building in different parts. Generally, two methods are employed in this type of air conditioning system. These are the air circuit of the condenser and the evaporator are interchanged by dampers which are automatically controlled. The second process, the direction of the flow of refrigerant is changed by some means. According to the space of use, room air conditioning. The room air conditioning are commonly used to cool and regulate the temperature of individual rooms or specific areas within a building. They offer targeted and localized cooling where individualized temperature control and comfort are essential. Central air conditioning. Central air conditioning systems are used to cool entire building or large areas. They consist of a central unit that cools and dehumidifies the air and then distributes it through a network of ducts and vents. The installation of this type of air conditioning system required careful consideration, preparation, and planning. The system's functionality depends on its size. The utility cost will be higher than they should be. Vehicle air conditioning. It is the system installed in the vehicles to cool and dehumidify the air inside the cabin, providing a more comfortable, controlled environment for the passengers. On the basis of construction of the AC. So number one, window air conditioner. Window air conditioners are small systems that are installed in a window or a hole in a wall. They are typically used to control a single room and are compact, affordable, and easy to install. In window air conditioner, as the blower starts moving, there is suction of air from the room. This air gets into contact with the evaporator or cooling coil. After the air becomes cool, it is allowed to enter the room throughout the outlet of the system. Refrigerant heated in the evaporator reaches its saturation temperature and begin to boil. The boiled gas is then sent to the condenser through the compressor. Generally, a hermetically sealed compressor is used in a room air conditioners. Split air conditioners. The split system has two main components, an outdoor unit containing the compressor and the condenser, and the other one is the indoor unit which contains the evaporator. After placing the units, they are connected by proper suction and liquid lines. The pressure of the suctions and the liquid lines changes with the distance between the indoor and the outdoor units. So, this distance should be kept as minimum as possible. They are suitable for cooling individual rooms or spaces. Package air conditioner. Package air conditioner is a large room air conditioner and is generally used for higher range of loads like 5, 7 or 10 tones, etc. Package air conditioners are installed either on the rooftop or side wall of a building and generally used in places such as a restaurant, homes, telephone exchanges, and small malls. These air conditioners have high cooling and heating capacity and also capable of cooling the entire commercial building. Chiller air conditioner. This air conditioner is used in a very large and scattered areas where it is not possible to provide cooled air to all the places. There are two types of chillers, water cooled and air cooled. They work similarly throughout the most of the process until the refrigerant reaches the condenser. After going through the various types of air conditioner, let us now test our learning by attempting the following multiple choice questions. So learners, after answering these multiple choice questions, let us now move to the last topic of the session, that is to discuss about the common defects of an air conditioner. Air conditioners can experience various defects and malfunctions over time. Some common defects associated with the air conditioners are: number 1, the compressor issue. The issues with the compressor can result in reduced or no cooling. Common problems include: compressor makes sound but does not start. Compressor starts but immediately stops. Compressor running continuously without giving proper cooling effect. The capacitor burnt out or high pressure head, etc. are the some common defects associated with the air conditioner when some problem arises with the compressor. The next defect is the fan or the compressor not working. When both the compressor and the fan are not working, the problem is most likely in the electrical circuit. So you have to check the fuse first, then the supply voltage, then the switch and the power cord. But if only the fan is not working, then you should check the capacitor and winding of the fan motor. If found to be defective, then the concerned part, that is the capacitor, is to be changed or winding is to be rewound. On the other hand, if only the compressor is not working, then first check the earthing of the compressor, and if the compressor is shorted for some reasons, it is to be rewound or changed. The next you have to check the capacitor of the compressor and the overload protector. If any of these are found to be defective, then change it. Thereafter you should check the thermostat temperature setting and adjust it if it is not properly set. Number 3 defects may be water leakage spot in the unit inside the room. Window or room air conditioners are fitted in room in such a way that about half of the system remains outside the room while the other half is inside the room. At the time of installation, the outside portion of the system should be kept at somewhat down level than the inside portion. That is, there should be a slope down towards the outside. So, when there are water droplets found inside the room, you have to check the slope and rectify the improper sloping. Poor or no cooling. When the compressor is working but the cooling effect is not proper, then there may be any of the following reasons. Number 1, shortage of gas. If there is shortage of gas, it may either be due to the insufficient charging of the refrigerant at the beginning or due to leakage in the system. It is important to inspect for any leaks. If detected, promptly repair them and replace the current refrigerant using recovery unit. The next issue is the improper setting of thermostat. If it is noticed, replace the thermostat. Capillary tube getting soaked. Due to the presence of moisture or dirt, sometimes capillary tubes get fully or partially soaked. compressor running continuously. For various reasons like shortage of refrigerant, high heat load, or compressor inherent problems, the compressor runs continuously without giving proper cooling effect. The cause is to be found and rectified. Fostering of the evaporator coil. It occurs due to improper setting of the thermostat, blockage of the air filter, or the fins of the evaporator. Low evaporator pressure or problem in the blower. In such cases, the evaporator has to be cleaned. The next issue may be the noise. The noise may be due to the vibration of the compressor or fan motor, which may be because of the damaged base plate of the compressor and the loose fan belt, etc. Improper placing of the front gills or refrigerant tubes, which may touch rotating parts like fan or blower. Next is the damaged cabinet or loose bolt nuts. So, dear learner, after going through these topics on the common issues of an air conditioner, let us now test our learning by attempting the following questions. So, dear learner, here we come to the end of the session, and at the end, I would like to summarize what we have discussed in this session about an air conditioner. First, the air conditioner is a process which controls temperature, humidity, velocity of air, and also purifies the air in a closed space. The process of air conditioning involves mainly three steps: heating, cooling, humidification or dehumidification, and air purification or cleaning. The main components involved in absorption and rejection of heat at specific point are evaporator, compressor, and condenser. The working process of air conditioners are involved. In the first step, heat is absorbed by the evaporator coil. Second step, compressor raises the refrigerant temperature, then heat is transferred outside, and after that the refrigerant gets cooled. Process repeats. There are many types of air conditioning system. On the basis of seasons, it is classified as summer, winter, and year-round air conditioning system. On the basis of the place of use, AC is classified as room air conditioning, central air conditioning, and vehicle air conditioning. On the basis of the construction of the AC, it is classified as window air conditioning, split air conditioning, package air conditioning, and chiller air conditioning. In the last, we have discussed some common problems that may occur in the air conditioning system. So, learners, I hope the information given in this session would help you to enhance your knowledge about the basics and working of an air conditioner. In the next session, I will come with some more information on air conditioner and some demo videos. Thank you very much.